All right, let's talk about AI engineering. Right now, it feels like every company on the planet is racing to build AI products. But you know what? A lot of them are really struggling. So today, we're going to cut through all that hype and figure out what actually works based on some amazing insights from industry expert Chip Hoyen.
So this table right here, it went totally viral. And for a good reason. It just hits a nerve. You see, on the left, you've got the hype cycle. Everyone's chasing the latest news, the shiniest new framework, obsessing over vector databases. But on the right, that's what actually moves the needle. It's the fundamentals, like talking to your users, building a solid platform, and just getting better data.
So to really get to the bottom of this gap between the hype and the reality, we're going to walk through 5 key areas. We'll kick things off with how these models are even trained in the first place, then look at the huge role human feedback plays, see how that all applies to building real products, and then we'll look at how all of this is changing the future of work itself.
Okay, first up, let's just decode the training process. We all hear about training AI models, but the thing to understand is that it's really 2 very different stages. First, you've got the massive, super expensive pre-training part, but then there's the post-training part, which is way more accessible, and honestly, it's where most of us can actually make a huge difference.
Here's a really simple way to think about it. Pre-training, that's like sending the AI to university to get a general education by reading, the whole internet. It gets a ton of broad knowledge. But post-training, that's more like a specialized apprenticeship. This is where you feed it curated expert data to teach it very specific, high-value skills. And for most of us building things, this is where the magic really happens.
You see, at its core, pre-training is all about something called language modeling. It's really just predicting the next word, or token, based on statistics. And get this, it's not some crazy new idea. It's the same logic Sherlock Holmes used to crack a code. He knew E was the most common letter in English, so he just assumed the most common symbol in the secret message was probably an E. These AI models are doing the exact same thing, just on a scale that's almost impossible to imagine.
And this leads to a really critical point. Those big pre-trained models, fresh out of their internet university, they're often horrendous. Seriously, they can be wildly unhelpful. It's the post-training, that refinement process, that turns a kind of messy genius into a genuinely useful tool. This is where the big labs spend a ton of their efforts, and it's where the biggest improvements are made today.
So that brings us to one of the most powerful post-training tricks in the book, the human feedback loop. This process is how we teach a model to stop just predicting the next word and start being actually helpful.
The technique is called RHF, which stands for Reinforcement Learning with Human Feedback. The reason it works so well is because it taps into a really basic human thing. We're actually not very good at giving an absolute score, like a 7 out of 10. But we are great at comparing things. It's just way easier to look at 2 AI-generated responses and say, yeah, that one's better. So here's how it works. It's pretty simple, really. First, the model spits out a few different answers. Then, a human, or sometimes another AI, looks at them and just picks the best one. All of that preference data is used to train a separate reward model. And then, finally, the original model gets fine-tuned using that reward model as its coach, basically teaching it what a good answer looks like.
Okay, so we've got the core concepts down. Now, let's dive into the messy reality of what it's like to actually build and test AI products out in the real world.
I'm sure you've seen the acronym RAG everywhere. It stands for Retrieval Augmented Generation. The easiest way to think about it is like giving the model an open book test. Instead of making it rely purely on what it memorized during pre-training, you give it a cheat sheet, a bunch of relevant documents and context right before it answers your question. And this helps with factual accuracy a lot. And this just brings us right back to our first point, doesn't it? People get so hung up on which fancy vector database to use, but the biggest performance gains you'll see in RAG, they come from better data prep. Things like how you chunk up your documents, whether you add metadata, or if you generate hypothetical questions. It's just like that first slide said. Focusing on better data is way more important than chasing the latest tech. This whole thing leads to a really big debate in the industry. Once you've actually built your app, how much do you really need to test it? I mean, do you need these super formal, complex evaluations for every single thing you ship? Well, the pragmatic answer is that it's all about return on investment. Look, if you're building something for medicine or law, or you're operating at a massive scale where one mistake could be catastrophic, then yes, you absolutely need intense tyrannical evals. But for some low-stakes feature, sometimes just vibe checking it is good enough.
That engineering time you'd spend perfecting the evaluation could probably be better spent building a whole new feature that adds more value.
So what about productivity? This is fascinating. There was a randomized A/B test at a company where they split engineers into high, mid, and low performers. And the result? The high-performing engineers got the biggest productivity boost from using AI coding tools. It's like the AI just amplified the skills and problem-solving abilities they already had.
This shift in productivity, though, is just one piece of a much bigger puzzle. It's pointing towards a huge transformation in how we work, how we structure our teams, and even the kinds of skills we're going to value in the future.
So, what's coming next? Well, for one, organizations are going to restructure. The lines between product, engineering, and even marketing are getting really blurry. We're also seeing a shift in focus away from huge pre-training breakthroughs and more toward clever applications and post-training. And finally, there's a huge push into multimodality. That means voice and video, which is bringing a whole new set of challenges, like how to deal with latency and detect when it's natural to interrupt someone in a conversation.
So with all this powerful automation and these incredible new tools, it begs the question, right? In this new world, what's the most valuable human skill going to be?
This quote just nails it. A lot of people think computer science is about coding, but it's not. Coding is just the tool. The real skill has always been system thinking, understanding how all the pieces of a puzzle fit together to solve an actual real-world problem. An AI can write a function for you, sure, but can it figure out why an entire complex system is failing? That big picture problem-solving skill, that's never going away.
And this leads us to a really strange paradox. We now have these incredible tools that can execute almost anything we can think of. So the bottleneck isn't execution anymore, it's ideation. We're kind of in an idea crisis, where the hardest part isn't building the thing, it's knowing what valuable thing to build in the first place.
So, as we wrap up, here's the thought I want to leave you with. As AI gets better and better at automating the how to write the code, how to generate the image, our most important and lasting value is going to come from defining the what and the why. You see, an AI can generate the answer, but can it ask the right question? That's where we come in.